Hey guys, welcome back. Hope you guys all had a great Monday. And so today what we're going to do is do a little bit more on that worksheet from the other day. So looking at the note sheet here, page 1, 2, and 3 were what we talked about on Monday about exponential growth and exponential decay. Remember, B is the letter attached to X, and if B is greater than 1, like right here, then it is going to be exponential growth. Okay, that means when you look at the graph left to right, the graph is going up. However, if you look at the graph and it is the letter B is between 0 and 1, not negative, but between 0 and 1, then it's going to be exponential decay. So the graph's going from left to right, it's going down, it's getting smaller. Okay? So what we're going to do today then is we are going to do problems on page 4. We are not going to do the exponential growth one on page 5, example number 4. We aren't going to talk about problems like that, so we're just going to work through the problems on page 4. So looking at this problem here, this is similar to the one you have on your homework. It says, the value of a car Y in thousands of dollars can be approximated by the following amount. Well, where does that come from? Well, it's important to know the two equations that can make an exponential equation. They are y equals a, parentheses, 1 plus r to the t. Okay, this one here is for growth. So when they're talking about something getting bigger or growing, that's the equation you're going to use, the 1 plus. But when they're talking about decaying, so let's say the value of a car. When you buy a value of a car, that depreciates pretty quickly. So that equation would be y equals a, parentheses, 1 minus r to the t. So that would be our decay equation there. R is going to be your rate. So R equals your rate. Okay. A is your amount you're starting with. Okay, so it's your starting amount. And T is going to be the time. And let's put down here with amount, let's do starting. Because your Y is going to be what the amount is at the current time that you're looking for. Okay, so let's go back and look at that equation. So it says, the value of a car Y in thousands of dollars can be approximated by the following model. 25, parenthesis, 0.85 to the T, where T is a number of years since the car was new. So we all know, for the most part, when you buy a new car, it depreciates in value. So that should be the decay equation. So it should be this one right here. It says, tell whether the model represents a exponential growth or decay. It represents decay. Identify the annual percent increase or decrease of the value. Well, we know it's going to decrease. So what we do is we take this part right here, this 0.85, so for B, we take the 0.85 and we set that equal to 1 minus R. So that tells us I got to figure out the rate there, and I know the 0.85 is inside the parentheses. So I need to solve for R. So I'm going to subtract 1 from either side, and I end up with negative 0.15, right, equals negative R. So I divide by negative 1, so I know my rate is 15%. Because 0.15 is our decimal, and again, in order to change a decimal to a fraction, I multiply by 100. So on letter B, where it says identify the annual percentage decrease, because it's decaying, it would be 0.15, which is how they got that answer right there. And then C says, estimate the value of the car when it will be $8,000. Well, what you could do is plug this into your graphing calculator and solve. However, what you also could do here, and it goes back to solving equations, which is what we've talked about, is do 8,000 equals the value of the car, which is $25,000. So actually, instead of putting that $8,000 there, what I'm going to put there is just 8. So because everything's in thousands. So I get 8 equals 25 and then 0.85 to the T. So what I'm going to do from there is I'm going to divide both sides by 25. So when I divide both sides by 25, I do 8 divided by 25. And I get as a decimal, let's try to keep that as decimal, not as fractions, 0.32. So I get 0.32 equals 0.85t. Well, this is an exponential equation, so I'm going to change it to a log equation to solve. So I'm going to get log base 0.85 of 0.32 equals t. So when I type that in my calculator, again, your base is 0.85. Make sure you type that in correctly. And I hit enter. I get t is approximately a little over 7 years, but 7. So I could either type it into my graphing calculator like they say to do so on C. However, I should have enough background information to be able to solve it, learning what we learned about last week and the week before spring break. Okay, so that's how you would do that one problem on your homework. And let's do a couple more just to make sure. So on the next example, example 3, it gives you the same thing. It says in 2000, the world population was 6.09 billion. During the next 13 years, the world population increased by 1.18% each year. Write an exponential equation given the growth model and estimate what the population would be after it starts 2000 at 2005. So what I do there is I'm going to use the growth equation. So I'm going to come up here and I'm going to use this equation right here. And I'm going to plug in what I know. So for this example right here, I get y equals, it says 6.09 billion. So I'm not going to write out all those zeros. I'm just going to write out 6.09. Okay? And then it's going to be 1 plus, here's the issue where most people are going to make a mistake. You have to change that percentage to a decimal. And in order to change your percentage to a decimal, you divide by 100. So I just move the decimal point to the left twice. And so when I do that, I get 0.0108, right? 0.0108. Actually, this should be 0.0118. So let's go back and change that real quick. Sorry. So that should be 0.0118. Okay? So 0.0118 plus 1 because we're in growth. And then I don't know my years yet, so I'm going to put a t there because right now I'm just putting the equation. So my answer here would be, for the equation, would be y equals 6.09, 1.0118 to the t. So that would be my equation for letter A. And then for B, it'd say, okay, now what's going to be the population, okay, from 5? Well, that's 5 years. So that's talking about years, and that's time. So what all I do is I take that 5, and I plug it in to the equation, and then hit this all on my calculator, and I solve it. And I should get this answer right here, about 6.46 billion. Okay? Make sure when you type this in your calculator that you don't multiply the 6.09 times the 1.0118. You have to do order of operations, so you're going to have to take it to the 5th power and then multiply it by 6.09. Okay? And then the last problems, let's look at these problems right here. Let's look at examples monitoring progress 5 and 6. So it says, in example 2, the value of the car can be approximated by the following model. Again, we know that a car depreciates in value, so that number attached to t is between 0 and 1, so we know right away that this equation is decay. Okay? So we're going to use that decay equation. So identify the annual percentage decrease in the value of the car. So I know that decrease is 1 minus r, and I know that inside my parentheses I get 0.9. So to find the decrease value, I solve this equation, and I subtract 1, and I get 0.1 equals, negative 0.1 equals, negative r. So r equals 0.1, which is 10%. So my car depreciates in value at about 10% per year. Then it says, estimate when the value of the car will be 8,000. So this is again is what I did before, is I'm going to take the 8,000 and set it equal to my equation and solve it. I'm going to divide by 2,500, but again, we know the value is in thousands, so instead of being 8,000 here, which is a lot of people would write there and get it incorrect, you're going to put 8. And then I would solve it from there, okay? And you should get approximately 10.8 years. I would take, say, approximately 10, approximately 11. Either way, I would take it because I know you're trying to round. And then what I want you to do for the last problem before you get on Zoom tomorrow is I want you guys to attempt number 6. I want you to look at that and say, okay, with the increase of 1.5%, I want to estimate that equation, and I want to estimate that in the year population will be 7 billion. So try to do that on your own. The answers right there are in blue, so you have that for both of them to kind of check your math. And then when you get on to Zoom tomorrow, ask any questions that you have through any of these problems, okay? And again, the 2 problems on your homework, or 3 problems on your homework, I'm sorry, it'll be the word problem one, and then the ones where they're asking you to find the rate. And in order to find the rate, we will do exactly what we did right here. We would figure out if it's a growth equation or a decay equation, set it equal to either 1 plus r or 1 minus r, and then solve from there. Okay, I hope you guys have a fantastic day. And again, you have an assignment due Wednesday at 11:59. On Wednesday, we will cover the next couple slides of the PowerPoint that have to do with compound interest. Have a great day, enjoy the weather, and hope to see you on Zoom tomorrow. Answer any questions.